Law of cosines is for when law of sines doesn't work. It's the easiest way to think about it. Law of cosines is, it's going to look really kind of odd. It's going to look a little weird. But what I want you guys to think about is, when do you use law of sines? Well, we use law of sines. You're going to use law of sines when you know an angle and a side opposite it. That's when you're using law of sines. Okay? You're using law of cosines when you don't. Law of cosines is for when you have law of cosines is when you have the following: two sides and the included angle. Think about the law of cosines. You use it when you have side, angle, side, or side, side, side. That's when you're going to use the law of cosines. Cis or sassy? Sure. Now, when you have the law of cosines itself is going to look rather weird. Yeah.
Sorry, so we have angle A and then side B and C.
Yeah, you're going to have an angle and the sides that make up the angle is basically what you're looking at, or you're just going to have all three sides. Okay? You're going to either have, this is what I'm showing, like the side angle side, or you'll have all three sides. That's when you use the law of cosines. So here's what happens. When you have the law of cosines, it's written out a couple of different ways. What I like to think about it is the following. You take the side opposite your angle. I'll get my little a over here. You square it. That will equal, if you need to get a drink, go ahead. Something about to die. That will equal the other two sides, like that. Subtract these two sides, multiply together, and then you take the cosine of the angle between them. It's very easy. You write it out a couple of times and you'll have it down pat. Seriously. It's a formula that if you write it out before you fill in the blanks for it, it comes rather quickly. I've never seen a song for this one. It would be pretty cool. So, again, what the book does is, obviously there's three different possible scenarios for your sides and your angles that you'll be working with. I like to just keep it generic. It's the side opposite an angle, sum of the squares of the other two. Okay? This is a lot of calculator work. Straightforward, just calculator work. Let me show you an example. Let's see, little a is 12, little c is 16, and angle B is 38. This is what we would call that side angle side scenario. Everybody see that? Now, when you're looking at this, again, think of it as you're going to work with the side opposite your given angle if this is the scenario. What is this side opposite the given angle? It's little b. Everybody agree? Yeah. Okay. So here's what I would do. I'd write out that's my side opposite the given angle. I square it. That's going to equal my other two sides squared. Minus 2 times 12 times 16 times the cosine of 38.
How does the person solve this?
Not a clue.
That's so hard.
Again, yeah.
How do people come up
Oh, I don't know.
Where did you come up with that?
Again, in this case, all we have to be able to do then is basically type it in the calculator. 12 squared plus 16 squared minus 2 times 12 times 16 cosine 38. And hit enter. Okay, that's equal to b squared. What do you have to do?
Root it.
So you square root it. So take second square root of your answer and hit enter, and you get 9.87. Yes, ma'am.
So this is just like some lesson where like the A and B.
They float around. Yes, they're going to float around a little bit. The book does write this out with the 3 different letter possible combinations. I don't think it's worth it because then you got to memorize 3 different things. If you just remember that you're dealing with the angle and the side opposite, and the other 2 just fall into place, you'll be okay. All right. Yes.
Why did anybody just like a mathematician just sit down and say, you know, we need to do
There's a lot of inference that happens. There's a lot of ways that people come up with these things. There's no reason for us to show proof. I mean, I could show you guys how they come up with all this. I just would have to research it myself. Okay. So B, what was it? 9.87. Now, what am I going to use to find angle A or angle C?
Law of sine.
Law of sines. What happens here, guys, is you could use the law of cosines again if you'd like, but sometimes using law of cosines more than once can get messy because there's a lot going on. If I set up to this scenario, I find an angle with the side opposite now. Now I can just work with that as a law of sines. Yeah.
How do you do side, side, side?
I'll show you here in a second. Okay, there's one little rule you have to worry about with that. So now from here, I'm going to use the law of sines. The sine of 38 is to 9.87, as the sine of C is to 16. Again, straight calculator at that point. 16 sine 38, hit enter, divided by 9.87, hit enter. And now that's going to equal the sine value of angle C, the second sine of my answer, 86.41.
Yes.
And then you know your other one.
All you have to do is just add them up, subtract from 180. Okay? Now again, you are going to have to take a leap of faith that you're doing the math correctly because there's nothing that you can reuse givens with here when you're using law of cosines. Okay? Really isn't, hopefully isn't so bad. The side version though is where things can get messy. Because when you have a side, what are you missing?
The cosine, whatever.
You're missing the angle value. So you have to learn how to, it winds up being a 3-step equation. So again, what I like to do is I start by drawing out my diagram. Let's see, little a is 8, little b is 18, little c is 13. And there is an important trick to remember when you have side. When you have a side case, you always want to use the law of cosines to find the largest angle first. The reason we do that is because if you choose a smaller angle, you can wind up getting an acute angle, correct? If you have an acute angle, then you have to test all those things with the law of sines. If you go for the large angle automatically with using the law of cosines, you might get an obtuse angle, which you don't have to worry about those other 4 weird things that could happen. So which of these 3 angles should be the largest? Everybody agree it's B? Yes. So I know that I'm going to use the little b as the side. Here's what happens. B squared is going to be the other 2 angles, or other 2 sides, minus 2ac, and then the cosine of angle B. Do you notice how I'm just reusing the letters within the pattern?
Yeah.
It was a very quick, sarcastic yes. Yes, sir.
So the same exact thing?
Yeah.
Okay.
It's the same exact thing. Notice all I did here is I'm using angle B and the side opposite. So instead of having angle A and the side opposite at A, just use it with the B's, and I just changed out my
That
letters.
is the exact same thing.
It's crazy.
Actually.
Again, start filling in the blanks. You have 18 squared is 8 squared plus 13 squared minus 2 times 8 times 13 cosine of b.
Oh, and then
Here's what I want you to do here. Making sense when I say it like that. Does everybody agree that in order to move the 8 squared and the 13 squared, you're going to have to subtract them? Okay. In my calculator, I'm going to type in 18 squared minus 8 squared minus 13 squared and hit enter. I got 91. Are we okay with that?
oh, domain doesn't
It will.
work. It will. Domain doesn't work.
Because you divide by negative.
Ooh.
Take a look at what happens here. When I move all those over, now I'm left with negative 2 times 8 times 13 times cosine. I have to remember to bring that negative down with me. If I don't, then I'm going to get those domain errors. Okay? So take a look at what you have here. Negative 2 times 8 times 13 times cosine. How am I going to move all three of those numbers at the same time? Divide. So in my calculator, I take the 91 and I divide it by parentheses, negative 2 times 8 times 13. I have to make sure I put that in parentheses, because if I don't, it's just going to divide it by negative 2, and then it's going to take that value and multiply it by the other two terms. And now I get some negative decimal. Was it negative 0.4137 or something like that? 437. And now, what buttons do you have to press to solve for the angle? Second cosine of that answer, hit enter. I get 115.94. Angle B.
And then it's just all signs.
Then it's just law of sines from there. Again, the reason why you are getting that cosine value of the angle turns out to be a negative number is the following. When we get to the unit circle, it's based off of the 4 quadrants. They're both positive here, negative and positive, negative and negative, and positive and negative. This is 90 degrees. Do you agree? So if this is 115, it's over here. Okay? What happens is, I think we mentioned this in class last week. The ordered pairs goes cosine and then sine. What's happening here is that in this quadrant, cosine values between 90 degrees and 180 degrees are always negative. The sine values in that quadrant would all be positive. That's why you're seeing a negative number. Yes, sir?
Wait a second, so the cosine of b is equal to negative 0.37. Do you do it in your calculator with your cosine, the inverse cosine,
Yes.
and then plug that in?
Yep.
and then it's-
Yep. Because if you're doing this string all the way through in the calculator itself, you've got this answer already stored in it, the negative 0.4375. So you hit second cosine of that second answer, and it'll already be there. What I did here is I just wanted to show you guys algebraically how it all falls through. But once you do 1 or 2 of them, it's really not all that bad. Okay. Again, once you find that first angle, now you know that you've got an obtuse angle up here at B. Now you don't have to worry about your 2 cases with the law of sines. So could you use the law of sines then to find the next angle? What would be the next angle you're going to want to find? Yeah. You always want to kind of go in order, like in that descending order of largest and smallest. It just tends to keep you out of trouble. So you can just do a quick law of sines. And again, you'll notice it's really not all that bad. And I think you guys did this last year, right? You didn't do this?
We did the law of science last year.
Yeah, Yeah, we did law
We
science.
didn't do.
We didn't do law
like,
cosine.
cross multiplying.
We just said.
I got C at 40.5. Anybody else get that?
Yeah.
Okay. And then to get the last angle, you just subtract out.
It's 23.56.
23.56. Thank you, sir. There you go. Okay. Again, when we're using the law of sines, law of cosines, you're going to be solving the triangles just like we have been, finding all the bits and pieces for it. Let me give you another one with all three of the side lengths. Like I said, those are usually the ones that most people have issues with. Yeah.
Oh, never mind.
So take a second, and what I want you to do is solve the triangle given just the side lengths.
So like what we just did.
Yeah, please. Try that with this one.
I didn't.
Let's see how we did. What angle did you guys try to find first?
I found A first just because 100 was the largest side.
Yeah. Again, you always want to get the largest angle out of the way first. It's the easiest thing to do. You don't run into any problems. So you get A squared is B squared
So
plus
then it's
C
just the
squared
original problem.
minus 2A, or excuse me, 2BC cosine. 100 squared is 61 squared plus 55 squared minus 2, 61, 55 cosine of A. Now in my calculator, here, then we have 100 squared minus 61 squared minus 55 squared, hit enter. Divide that by parentheses, negative 2 times 61 times 55. And that's my negative, that's what my cosine equals. Second cosine of the answer, and there's your angle A. 119? Guys get 119?
I did 119.01, but
0.01 were.
Yeah.
101, not even
119.01. From that, can you guys use law of sines to find the next angle?
Yeah.
I just do it
about law
for
of
both.
tangents?
There is no such thing. Yes, sir.
Oh, I'm pretty
Why
much.
did you switch 61 and 55? But interchange. Oh, it doesn't matter.
It was when you have 61, when you're adding and multiplying, the order doesn't matter. It was just that I just wrote down a
For
number.
OCD's sake, it does.
For OCD, yeah, for OCD's sake, if you keep them all straight through, you're fine.
That kind of stuff was bad.
Because isn't 2 times 3 the same thing as 3 times 2?
Yeah. No, I was just curious. I got
You get that chain, you get that chain, divide them into
Curiosity.
You might have typed the wrong number. If anything, you might have typed it in
the 61 squared plus 55 squared plus 100 squared. And then you divide by the negative 2 times those. Then you divide the result by the negative 2, whatever it is. And then you.
I didn't hear you.
So that's 100 squared minus the other 2.
So, triangle has a square.
No, oh, yeah, but like I was.
Kidding me,
No,
right?
I used the wrong numbers.
There you go. That's what it was. Yep, that's why you're off. That's why you're off. Remember, because you're subtracting these two over, and then you're dividing by those values. Okay. Not so bad. Let me give you a couple of problems then for tonight. Oh, there it is. We'll get into the Heron's formula tomorrow. Remember, when you're doing these things, be careful. You could come across two triangles set up with law signs still.
You literally have to check every time you see her.
Get those. All right? Yeah, if you don't mind. No, you know there's like a dead spot right here.
Page 8.
There it goes.
Those are done spot.
Hey, that's not nice to say to your friend.
Not my friend.